For our test review, we're going to write down some rules and then we're going to do some examples. I'm going to separate what the test will be on in like 4 parts or 4 different types of examples. But just to have some written rules, we have a right triangle where the C side is the one directly across the 90-degree box. So let's say we have some numbers here. So the rule is if I have C and if I don't have C. So this is for us solving the missing side, which we've already done, but I want to give you this as a written word rule. So the setup, if we have C side, which means if I have a number here on the C side, if I have it and I were missing A or B side, we would do square root, square, square, and we would be subtracting the numbers that we have. So if I had 8 and 6 and I was missing B side, for example, we would do 8 squared minus 6. But if I don't have C side, let's say I don't have C side and I have A and B side, I'm missing C side, we would do square root, square, square, and we're adding. So I would be adding 6, which is A side, and I would be adding 5, which is B side. So if I have C, we subtract the 2 numbers. If I don't have C, we add them, square root it, and then square them down from there. So that's for the missing side portion of the test. For angles, if we're solving for angles, so we could put missing side here, missing side. If we're missing angle, missing an angle, this is simple because it's just one rule. So, So 90 degree, let's say we have 32 degrees and I'm missing an angle. So this rule doesn't change. Since it is a 90-degree triangle, we're just gonna do 90 minus the given angle, which is 32 here. And that's it. Whatever you get for that is your missing angle. It doesn't matter which way the triangle goes. So if this is 49, we would do 90 minus 49 for our missing angle. So remember that on your test, you will have to solve these 2 parts, missing side, missing angle, and then we're doing the Pythagorean, not Pythagorean, sorry, we're doing the trigonomic ratios. So just to have that written out, our ratios are so, ka, so those are the main ones. And then remember that the direct opposite would be secant is HO, secant is HA, and cotangent is AO. So again, these are direct opposites of each other. These are direct opposites of each other. And these are direct opposite, but we only use this when we have just one angle in the triangle and we can just flip it. If not, then we use them as separate trigonomic functions, but those are the 6 and we're still going to use all 6 of them. Doesn't matter if we have 2 angles or not. So now your test will be basically what we did in the last section. Solving the missing angle, solving the missing side, and then supplying the trigonomic ratios. But I wanted to go over just one more time the breaking down part of a missing side. So remember that we're going to have either a perfect square or we're going to have a non-perfect square, which we have to fix the bottom of it, of the fraction. So let's say, let me see, let's say we have 12 and 14. So we'll do one angle for this one. Let's do 32 degrees. So I want for this one A, B, C. For this one, I just want the missing side, which is B, C. And then we'll do our ratios. So here we have the C side, which is across. We have the C side. That means that we're going to do the square root of 12 and subtract 14 squared. So we're subtracting because we have C side. Wait, we have to do these backwards, sorry. Big number goes first. So 14 here, 12 here. So let's do this backwards because we can't have a negative. So 14 squared minus 12 squared. So that gives us 140, not 144. That gives us 196 minus 144. 55. It is 52, sorry. So 52. So we can break down this number to 26 times 2. 26 breaks down to 13 times 2. So for your test, if you have a perfect square like 25, we would have just put 5 and that's it. For this case, 52 is reducible, or we can simplify it, not reducible. We can simplify it. So we will simplify it. So this becomes a pair of 2's and then 13. So our missing side, we'll put it over here, is 2 on the outside, which is what we circled, and on the inside we have square root of 13. So here we have 2 square root of 13. So when we make our pairs, we want to replace the square root of 52 with 2 times square root of 13. So now let's do our ratios. So we have it as a reference at the top, at above it here. So let me shrink this. Oops. Okay, so we're gonna do sine. So we only have one angle, so we're doing sine of 32. Cotangent, not cotangent, sine cosine of 32. Sine cosine tangent of 32. And then we're gonna do cosecant of 32. Secant and cotangent 32. So again, we have our trigonomic ratios up here. So we're going to go by that. So the first one is sine. Sine is opposite over hypotenuse. So we're looking at this. Opposite O over H is opposite over hypotenuse. For this one, we can label. We'll label our pieces. The C side is hypotenuse, so 14 is H. Opposite would be 12, and adjacent, my neighbor, would be 2 times the square root of 13. So if we label it, it makes it a little bit easier just for this one because we're only using 32 as a reference. We're not using the other angle, which we will for another question, just not this one. So we're doing opposite over hypotenuse. So O over H would be 12 over 14. So we just want to reduce this with, we can do 2, which will give us 6 over 7. And then we can flip that on this side because, again, we are using the same number for all of them. So we can go ahead and flip it for the other side. Next, we have cosine of 32. So we're doing A over H, adjacent over hypotenuse. So this would be 2 square root of 13 over our hypotenuse of 14. So here, remember that we can split this as 2 over 14 times the square root of 13. So we can reduce that outside fraction. 2 and 14 are reducible with 2, making it 1 and 7. So our answer here would be 1 square root of 13 over 7. So that would be our answer for that one. And then we will flip it for this side, which means it will be at the bottom. So this would be 14, 2 times the square root of 13. So we still want to split 14 over 2 times the square root of 13 is at the bottom, which we will bring up. So we can bring this up. We don't bring up the 2, we only bring up the root of 13. So this will be up here now, and then the 13 comes out. And then we're gonna do 14 divided by 2. That gives us a whole number of 7. So what do we have left? We have 7 at the top, square root of 13 at the top over 13. Because remember, that number comes up and it also goes underneath the fraction. So that is our answer for that one. And then for tangent of 32, tangent is opposite over adjacent. So again, just follow those ratios. Opposite is 12, adjacent is 2 square root of 13. So we're gonna do the same process we just did for secant of 32. So we're gonna split it 12 over 2 times the square root of 13, or actually on the bottom, square root of 13 at the bottom, which we're going to bring up. 12 divided by 2 is 6, whole number of 6, so that will be at the top. The 2 is gone because we divided it with 2 completely. We brought up that square root of 13. So our official answer for this one will be 13 over 13. And then for a tangent, it's the opposite. So we're doing 2 square root of 13 over 12. We want to split this as 2 over 12 times the square root of 13 at the top. And here we're just going to reduce 2 and 12 with a 2. So that becomes 1 over 6. So our official answer here is 1 square root of 13 over 6, where we don't have to fix the 13 because it's not at the bottom. So we can leave it inside of the square root box, and we already reduced it. So our answers here would be 6 over 7, 7 over 6, 1 times 13, square root of 13 over 7, and then 7 times square root of 13 over 13, 6 times the square root of 13 over 13, and 1 times the square root of 13 over 6. So those are our 6 answers after we found our missing side and we reduced it. So that's what we're going to be doing on the test, as well as solving the missing angle and going off of that angle for the trigonomic ratio. So we'll do one of those, and that would be it. So pause the video up here if you have to finish writing that down. Go ahead and take a second to finish writing that down. So some of the triangles will have just one angle, some of them will have 2 on your test. So the one that we just did was the one that has 1. So let's do one that has 2. So let's do 8 and 10. So for the one up here, we did have seaside. Here we don't, so we can practice that part as well. And then I'm gonna give you the angle. Let's do 39. And then we're missing this one, so L, M, N. So I want the missing angle, and I want the missing side, LN, and then we're going to do, let me rewrite these. So, I rearranged the, I paused the video and rearranged it, but So those are our 6 trigonomic functions. We're looking for the missing angle, missing side, and then we'll do our 6 ratios, which I will write. So we're gonna do sine of 39. We're gonna do cosine of n, tangent of, let's do n. We're gonna do cosecant of n, and then secant of 39, cotangent of 39. So again, we're going off of 2 different angles here, 39 and n, which we're gonna solve, and then we're gonna do our ratios. So we're not gonna flip them like we did for the very first one because these will be a little bit mixed. So just go off of the ratios up here by the function. So let's solve the missing parts first. So for the missing angle, remember that all you're gonna do is do 90 minus the angle that I gave you, which is 39. So it doesn't matter if I give you one corner or the other, as long as you do 90 minus that number, you will get your missing angle. So we do 90 minus 39, that's 51 degrees. So we don't need that. That's not going to come into play unless you want to go ahead and like replace your ends. So I went ahead and changed out the ends for 51s just to make it a little bit easier, like visually, just in case that makes it a little bit easier. But you don't have to change it. On the test, it will be written as cosine of n or cosine of whatever angle we're missing, but you can go ahead and just like scratch out the letter and put the degree over it if it makes it easier. So we're going to do now the missing side. We are missing C side. We're missing C side. So we're going to do square root, square, square, and we're going to be adding our 2 numbers. So we have 10 squared plus 8 squared. That gives us 100 plus 64, which gives us a square root of 164. We will have to break this number down. So let's do, I'll do it over here. I want to rewrite that. I'll put it under here. 100 plus 64. So I have the space to work this out. So we have the square root of 164. We can break this down with, you can use 2. I'm going to use 4 times 41. 4 times 41. Let me double check that. 4 times 41. And then we can break down the 4 to 2 times 2. So we have 2 2's here. So our official missing side is 2 square root of 41, because that does not have a partner, so it stays on the inside. 2's came out on the outside. So our missing side here is 2. So we're going to go ahead and write that on our triangle. 2 square root of 41. So remember that our C side, the one that we just solved, is our hypotenuse side. So that's the only one you can mark because we have 2 angles here. So technically we have 2 opposites and 2 adjacents. So don't mark any of those, opposite or adjacent, but the hypotenuse is 2 times the square root of 41. So that one we can write it out so that we have that as a reference. So we're going to start doing our ratios. So sine is the very first one. So remember, we go in order. We're doing, just so that I can, let me see. We're doing this one, then this one, then this one, then that one, and then that one. So we're going in order. So we're doing sine of 39 is O over H, opposite over hypotenuse. So opposite to 39. This is 39. Opposite is 10. So be careful on which side you go from. We have 2 over 41. So we do want to break this down. So we can split 10 over 2 times the square root of 41. So we just did this. We know that we're going to bring this up and it's going to stay on the bottom. But we can do 10 divided by 2 evenly. We're not like reducing like a fraction. 10 divided by 2 gives me exactly 5. So our answer would be 5 at the top. We brought up 41 and we want to keep 41 at the bottom. That is our official answer for sine of 39. Do not flip it here because, don't flip it here because we're doing 51 for this side, not 31. So do not flip that answer. So cosine is adjacent over hypotenuse, a over h of 51. So adjacent for 51, opposite would be 8. We're not doing opposite, we're doing adjacent, which is 10. And then our h, which we have labeled, is 2 square root of 41. So this one actually ends up being the same answer as the top because we're doing 10 over 2 square root of 41. So go ahead and just write the same answer that we just wrote down, 41 over 41. Tangent of 51. We want to go from this corner. Tangent is opposite over adjacent, O over H. So opposite to 51 is 8 and adjacent neighbor is 10. Remember, the neighbor is also H, but H is its own side all the time. We don't put H as an adjacent. It's already our hypotenuse. So it's 8 over 10, which we can reduce with 2, making it 4 over 5. So that one's pretty simple. Next, we want to do cosecant of 51. Cosecant is hypotenuse over opposite. Hypotenuse, we know that it's 2 square root of 41 over the opposite is 8. So this one we do want to break it down. We can separate this as 2 over 8 times square root of 41 at the top. So we're not bringing it up, we're keeping it at the bottom, over 41. We don't have to do that here because it's not at the bottom like it was for the first and second one. So we can divide 2 and 8 with 2. 2 divided by 2, 8 divided by 2 will give us 1 and 4. So our official answer here is 1 square root of 41 over 4. Secant of 39. Secant of 39 is hypotenuse over adjacent for 39. So our hypotenuse, again, we know is 2 times the square root of 41. Adjacent for 39 is 8. So we just did this one as well. Again, adjacent is also 2 times the square root of 41, but that is our hypotenuse because it is across 41. So we want to make sure that we know that that will not be our adjacent side because that's the hypotenuse. Adjacent is 8 for this one. So this one gives us the same answer as the top, 41 over 4. And then last we have cotangent of 39, which is adjacent over opposite for 39. So adjacent is 8 over opposite is 10. So we're doing 8 over 10, which we can reduce just like we have over here with 2, which will give us 4 over 5. So our total answers for this one question, we have 1, 2, 3, 4, 5, 6, 7, 8 total answers for one question. That's what your test is going to look like. Or it's going to be like this one up here, which we also had. Actually, we have 7 for this one because we're not looking for the missing side. But the 2 are the same. We just added a second angle for this one down here. But same process, except we don't need that missing angle. But that is what's going to be on your test. Remember, some of these questions will be a little bit easier because you're going to have perfect squares. So you're going to have just 3 numbers. Basically, you're going to put like 8 over 10, 10 over 2, 5 over 4. So they won't all be like this long process, but some of them will be like this process, and you will be solving the missing side. So make sure that this rule up here, the very, very first rule, these 2 up here, make sure that you know those well, because if you do the opposite, if you add it when you have to subtract it, it's going to throw off literally all of your answers. So make sure that you understand that rule. If you have C side, you subtract. If you don't have C side, we add. So be careful with that, because then I don't want all of your answers to be wrong just because you misunderstood the first step. But that is what your test is going to look like. Some with perfect squares, some without them, some reducible and some not reducible. So that is what we're going to be covering on our next test. So go ahead and put a pause if you have to take these notes down. If you have any questions, let me know, and then be on the lookout for your practice worksheet in Google Classroom.